functions again today, but we're going to focus on changing the period and moving our graph left and right, which we are going to call a phase shift. There we go. All right, so we're going to start with some basic vocabulary and just a quick check of the sine function to make sure we understand the important features. Our sine wave, or periodic function, is simply the graph of y equals sine x. And we already looked at the amplitude in a previous lesson. The amplitude is just the height of the wave. And we know we can calculate the amplitude by taking the max, subtracting the min value, and dividing by 2. We can also calculate the amplitude by finding the midline and counting how far up we have to go to reach a peak, or from the midline how far down we have to go to reach a trough or a minimum. The period, which we're going to change today, is the length of the wave. And for the parent function, before we change it, it is 2 pi for sine and cosine. And related to that is what we're going to call the unit. That's going to be, when we graph, how are we going to label that x-axis? And that is going to be determined by the period. So the unit is how we label the x-axis. And a good way to do that and make sure you hit all of the important features of a sine or a cosine curve is to take the period and divide it by 2. Sorry, I said that incorrectly. I was thinking about our other comment there. This is to take the period and divide it by 4. We need 4 marks to get all the important features of our sine curve. So let's just graph the basic sine function. We can see how this idea of the unit works. The amplitude of the regular sine function, you can see there's no value in front, is just going to be 1. The period, we haven't changed that, is 2 pi, just a standard sine function. And when we find the unit, how we're going to mark the x-axis, we'll take 2 pi and divide by 4. And that shows us that we should put a mark every pi over 2 units to get all the important features of the graph. The domain of a sine or a cosine curve is always negative infinity to positive infinity. And in this case, our range, because we have not changed the amplitude or shifted our graph up or down, is -1 to 1. So when we go to graph, the first thing I like to do is think about my y-axis, the midline, and any vertical shift. There is none here, so our midline will be the x-axis. Our amplitude is 1, so I'm going to go ahead and mark the y-axis. Our graph will go up to 1 and down to -1. I just made each of those worth 2 boxes, just be consistent. And now, before we graph, we're going to mark the x-axis with the idea of that unit. And it said that we should put a mark every pi over 2. So we have the space here. I'm going to make each 2 boxes worth pi over 2. So we'd go pi over 2, pi, 3 pi over 2, all the way to 2 pi, so we can fit 1 cycle there. When you're graphing a sine curve, we always think that when we begin the graph, we're starting at the midline value, which is right here. And these 4 marks, these units that we've put on the graph, show all of the highlights of the sine curve. And the first thing the sine curve does is come up to a maximum, so we're going to hit that right here at pi over 2. And then our sine curve comes down, midline value, down to a minimum, and back up to our midline. And there's our standard or parent sine curve and how we would use those units to graph. So now we're going to change the period. And what we're trying to do here is start to put all of our transformations together. And we've already looked at amplitude. I'm going to label these vertical changes in red. The amplitude is the absolute value of A. That tells you how far you're going to shift up and down from the midline. And if we move our midline, it's this vertical shift, the number that's been added at the end of the graph. If we do plus D, then our midline moves up D unit. And if we subtract, very straightforward, our midline moves down d units. But what we haven't done is change the period or the phase shift. And the period and phase shift are both changes on x, so we want to remember that our x is a liar. So the period is going to be changed by b. And it looks as though b is multiplying by the x. We know that that's going to take the period and divide it by b. So our new period, if we change it, is to take our old period, our standard period of 2 pi, and to divide that by the b value. Looks like it's multiplying, but it's actually dividing. And that's the way we're going to remember our phase shift as well. It's with the x. Our x is a liar. So if it says x minus c, we are actually going to shift right by c units. And if it says plus c, we're actually going to shift left by c units, whatever that happens to be. So the first thing we're going to do from these two x changes is talk about changing the period. So anytime we have a multiplier in front of x, that's going to affect the period of our trig graph. And we're multiplying, in our example here, we're multiplying x by 2. So that doesn't mean that our period is going to be twice as long. It means we're going to take our period and divide it by 2. Our old period, the standard period, was 2 pi. We're going to divide that by 2. So our new period is pi. So in the space of a regular function, which would be 2 pi, now we're going to see 2 complete cycles. So we can also think of b as the number of complete cycles within 2 pi units. Where we used to see 1, now we're going to see 2. So since our period is pi, we need to get through the entire cycle and finish it by the time we get to pi. All right, thinking about the other features of the graph, our amplitude has not been changed. It is still 1. Our period, we just calculated that as pi. So when we go to think about marking our x-axis, our unit is pi over 4. We can't reduce that, so we're going to put a mark every pi over 4. Our domain would be negative infinity to positive infinity. And our range, because we haven't changed the amplitude or shifted our graph vertically, is negative 1 to 1. So as we go to graph, same as before, I'm going to mark my y-axis first. The midline hasn't changed. The amplitude is still 1, so I'm going to make that worth 2 boxes, totally up to you, just be consistent. Now we're going to mark the x-axis before we graph. And our unit is pi over 4. So I'm going to mark every box as pi over 4. So our first mark would be pi over 4, and then we're going to have pi over 2, 3 pi over 4, and here's pi. And I'm going to keep on going to 2 pi so we can see how the period has changed. This would be 5 pi over 4. This would be 3 pi over 2. This would be 7 pi over 4. And here we would have 2 pi. So we just counted by pi over 4s. And since our period is pi, that means when we go to graph, we have to finish the cycle by right here. So these marks before that are important features. We're still going to start our graph at the midline, which is right here. It's a sine curve. And each of our units is one of those important features. So we're going to hit our maximum. We're going to come back down to our midline, our x-intercept. Oh, I didn't make my maximum tall enough there. Sorry, I don't want to be misleading. We are going to start at the midline. We're going to hit our maximum. I put it up here. Sorry about that. And come down to our midline. X-intercept. We're going to come down to our minimum. And we're going to finish the cycle within pi units. So we can see that we have compressed that period. The other thing that we should know is because the b value was 2, if we go out here to 2 pi, which is where one cycle would end, and we continue our pattern, a b value of 2 means we can fit 2 cycles where there used to be just 1. So that's how we change the period. Next is going to be our phase shift, which is just another way of saying horizontal shift. So if you hear phase shift, we're just talking about moving it left and right. So we're going to graph this example, sine parentheses x minus pi over 4. We know that's an x transformation. It's grouped with x. And typically when we graph a sine function, we start at x equals 0 right there at the midline. But this graph has been moved to the right by pi over 4. So we're going to start our graph at the midline, but not at x equals 0, at pi over 4. So let's see what that looks like as we go to graph. As I do every time when I go to graph, I want to think about these features. The amplitude hasn't been changed, it's 1. The period, there's no multiplier in front of x, so it's still 2 pi, making my unit 2 pi over 4. So we need to see a mark every pi over 2. Our horizontal shift, that is minus pi over 4. Our x is a liar, so we're going to go right by pi over 4. The domain, negative infinity to positive infinity, and range. All right, so let's mark up our graph here. And I'm going to rely on what I've already done. Here's our midline. Here's our amplitude of 1 and negative 1. And our marks on the x-axis every pi over 2 for our important features of one cycle. So we've got our marks every pi over 2. Now what that means for this graph is that one box equals pi over 4. So I'm going to graph this y equals sine of x minus pi over 4 in 2 steps. First, I'm going to think about where the graph would normally be so I can see all of the important features, which is to come up to a maximum, down to the midline, to a minimum, and back up. We're going to shift this shape to the right by pi over 4, which is taking each of these important features and just moving them to the right by one box. So I'm going to do my final graph in green. I'm going to take this first point that's at 0, 0, and I'm going to move it to the right by one box. I'm going to take this maximum and move it to the right by one box. This midline value, this x-intercept to the right, this minimum to the right, and this x-intercept to the right. And here is the new sine curve. You can see it's that exact same shape. It's just been shifted to the right literally by 1 unit, and that is our phase shift. And of course, if we kept going, our graph would extend to the left and would keep going up to the right. But there is one cycle of our shifted graph. All right, and last we're going to put the period change and the phase shift together with our cosine curve. Just a quick review of cosine, amplitude of 1, period of 2 pi. Just as we mark the cosine graph with marks every pi over 2, we would do the same for cosine, has the same period. Our domain for cosine, same as sine, and the range also the same. So remember your important features of your cosine graph as we go through. We are going to mark our midline. Amplitude is 1. And just as we mark the sine curve with the unit of pi over 2, we're going to do that for cosine curve. All right, and here's our big difference. The cosine curve does not start at the midline value. Remember that the cosine curve begins at a maximum value. So we're going to start up here at our maximum value, which is 1. And then each of these unit values that we've marked on the axis is going to represent one of those important features. And the first thing it's going to do is come down and hit at pi over 2. That's our x-intercept or midline. Then we go to the minimum. up to another x-intercept at 3 pi over 2, and then to complete the round trip, we have to get back up to that maximum value at 2 pi. So that is the important difference to consider when you're graphing cosine versus sine. So everything works the same with a cosine graph. We have two possible vertical changes. Our amplitude would be the absolute value of that a value in front, plus d. The midline moves up d, or down. And we can change the period the same way. I need to emphasize that the parentheses should be here instead. But the same thing we do with sine, our period is 2 pi divided by b. Looks like it's multiplying, but it's actually dividing. And when we do the phase shift, just focus on the minus and plus c here. That's with our x, that's a liar. So when we subtract c, we're going to move to the right by c units. So our x is a liar. And here we're going to move left by c units. So let's look at what we're graphing next. We're going to graph y equals cosine 2 times parentheses x minus pi over 4. So we've seen both of these changes before. Now we're going to put them into one graph. So let's start with the amplitude. Has not been changed, that's 1. But we have a b value, that's going to change our period. So let's do 2 pi over 2 and see that our new period is pi. We have to complete that entire cosine cycle within pi units. When we go to mark our graph, we're going to mark it with our period divided by 4, or pi over 4. The domain does not change, still negative infinity to positive infinity, and our range, because the amplitude hasn't changed. So the other way we can talk about these is the same way we've talked about all of our transformations. This would be a horizontal compression. Or a shrink, because we're fitting more cycles into the same space. So we've compressed it from the sides like an accordion. Our phase shift, when we identify that transformation, we're going to go to the right by pi over 4, and we have no vertical shift. Nothing's been added or subtracted to the end of our function. So when we put all of these together, it's still going to start with midline and the amplitude of 1 and negative 1. And according to our calculations, when we mark the x-axis, our unit should be pi over 4. So pi over 4, pi over 2, 3 pi over 4, and pi. And we would have to get one cycle within these 4 boxes. We could keep going. Call this 5 pi over 4. And all the way out to 2 pi if we'd like to see 2 cycles. And I'm going to do this in 2 steps. I like to see where the graph would be within its period, within pi units, and then I'm going to shift it from there. So the first thing you're going to see me do is just to sketch in the graph without the phase shift. So remember, a whole cycle has to finish by pi, and that b value of 2 says 2 cycles can fit by 2 pi, which was where 1 cycle used to fit. So to me, this makes my graphing easier because now I can see all the important features. And our phase shift is to move everything to the right by pi over 4. And pi over 4 is one box on the graph. So each of these important features needs to move over one box. And we'll see that the final result is this green curve, where that shape that we graphed has just been shifted to the right by pi over 4.